is in, I think, 1.2. Is that right? I'm not 100% positive what page it was on. 1.2, I think. Yeah. Introduction. Yeah. So let's talk about these SI units. And in the process, also bring in significant digits as well, because they do all flow together. Your textbook loves, in the problems we're going to do, it just is infatuated with giving you one type of unit when actually you need a different type to solve the problem. Okay? And so we want to make sure you know how to convert. That's our key piece. Okay? So let's say that I have 1832 centimeters. And I want to know how many meters is that? Say again? Okay, so you know, because you have some experience with the centimeter scale, that how many centimeters are in a meter? 100. Centi means 100, right? So if I look back on this scale, we know that by the scientific notation or by the multiplier. Okay? What you have to see is that, and I don't know if this is going to work if I draw on here, but are you comfortable that right here is the line for meters? And everything below that is smaller than a meter. Everything above that is smaller than a meter. Everything below that is larger than a meter. Does that make sense? Because otherwise this table means nothing. It's just a pretty table if you don't understand that. Okay? So therefore, these things mean, I want to make sure you hear me, that if I take meters and I multiply it by 0.1, I get decimeters. If I take meters and multiply it by 0.01, I get centimeters. Are we cool? Or conversely, see this is a 10 to the 1. That means there are 10 decimeters for every 1 meter. Since this is 10 to the 2, this is 100 centimeters for every 1 meter. Right? So nanometers is 10 to the 9. That's a billion. There's a billion nanometers in 1 meter. Are you with me, friends? So this multiplier is simply if you're going from meters to the other thing, right? So this guy is going from meters to your other unit. The scientific notation is from your unit to meters. Does that make sense? So, back to our example. We know that there are 100 centimeters in 1 meter. Right? So I encourage you, the way that makes the most sense to me is to use it just like I taught you in chemistry, where we're using our skeleton and putting things on top and bottom based upon what we're going from and what we're going to. So 1832 centimeters. Are you comfortable that what's going to go on the bottom? Well, how do you know? Is it? We got to cancel out centimeters, right? So what has to be down here? Centimeters. And what has to be up here? Meters. What numbers go where? 1 on top and 100 on the bottom. Does that make sense? So therefore, I'm taking 1832, I'm dividing by 100, so I get 1.832 meters. That would be my answer. Now, I always encourage you to go back and think, does that make sense? All right? So let's look at our scale again. Which is bigger, centimeters or meters? Meters, right? So if I'm going from centimeters to meters, shouldn't there be a difference? There should be. Did I do my math wrong? Should be 18? Yes, thank you. As I did that, I'm like, wait a minute, Mr. Hess, that's not correct. I'm moving this 2 spaces, right? So my apologies. It should be 18.32. Thank you. Thank you, thank you. Sir?
So why is it like centimeter and decimeter like smaller?
Yeah. Yes? I hear what you're saying. 1,000 less. So taking a meter and breaking it into smaller pieces for 1,000, they say is milli, which again means 1,000 as well. Millennium is 1,000 years, right? For a larger, if I take 1,000 of that base unit, is a kilo. So I hear you. I hear you. And that's the key piece, is that these go both ways, right? Bigger than and smaller than the base unit. Yes, ma'am.
So when we're moving around on this chart, we're just moving our decimal point around?
You are.
Awesome.
That's all it is. For SI units, because the French were very smart and they made this just simply base 10. It's a base 10 system. It's all based upon 10. There are 10 of these for every meter. There are 10 of these for every one of those. There's 10 of, does that make sense? It's all base 10. So all you have to do is move that decimal place. Please understand, there are lots of other conversions, just like in chemistry, where we'll have different numbers than that up here. Right? It won't always be just base 10 pieces. But to go in the SI units, it's just simply moving decimal points. We cool? Let's try another one. Let's try another one. Okay? Let's see. How far away, estimated, would you say your home country is from here? Just an estimation. Kilometers. Any idea? How far away from here?
Almost 11,000.
11,000 kilometers?
Yes.
Okay, we'll take it. Let's make it a fun number. 632. I don't know.
Yes. Yeah.
We'll go something like that. Okay? And I want to know, because I understand centimeters really well, I want to know how many centimeters away is that? Whew. So, let me ask you again. I always encourage you, start with the common sense. Are we going to get a very large number or a very small number? Very huge number, right? Because I'm measuring humongous distances between places in tiny little centimeters, right? So we know it's going to be a big number. Okay? So, you've got 2 choices. Okay? If you are comfortable enough to make the jump from kilometers to centimeters in one step, you can do it. Okay? It's not hard. You're just adding the different pieces together. But I'm going to show it to you by going to meters first. So we're going to take 11,632 kilometers, and I'm going to first break it into meters. How many kilometers are in how many meters? Look at your chart. It's on page 11. 1,000 what, though? 1,000 meters in 1 kilometer, or is it 1,000 kilometers in 1 meter? Meters. And again, we know that because kilometers are bigger than meters, right? So this multiplier is dealing with the base unit. That's what I want to make sure you understand. The base unit. All right. So we've got 1,000 kilometers. Oops, wrong way. 1 kilometer is 1,000 meters. We cool? And again, like Clayton mentioned, we're canceling out these units. That's why we put one on top, one on bottom. So that's going to give me basically 3 zeros on the end of this, right? 11, 6, 3, 2, 1, 2, 3. We cool? And that's meters. But is that where I want to stop? No, let's keep going. We want to get to centimeters. So how many meters are in how many centimeters? 100 centimeters in 1 meter. So again, 1 meter on the bottom, 100 centimeters on the top. Whew. So this is a big number, right? 1, 1, 6, 3, 2, 1, 2, 3, 1, 2. Whew. That's an impressively large number. Okay? Can we put this into scientific notation to make life a little easier for us? So 1.1632 times 10 to the, anyone? 1, 2, 3, 4, 5, 6, 7, 8, 9. Times 10 to the 9 centimeters. And all that does is save us from all those pesky zeros. Because remember, for scientific notation, it's always between 1 and 9.9 infinity. That's always what we move the decimal point to get us to. Why did I get rid of all of these zeros? They're distracting. I would agree with that, sure. They're not significant. It doesn't give us any information. It just tells us about where the decimal place is. Right? Do you remember our three rules? There really is only two. Kirsten and I had a good discussion about this yesterday. There's really only two, but we call them three. Our significant digit rules, do you remember? Okay, so if you do that, we got 4 then. 1 through 9, always significant. Number 2, when is a 0 significant? Okay, so if it's between, that is significant. Number 3, when else is it significant? Okay, it's the final 0 after a decimal place. Does that make sense? So a number like this, 13.0, that 0 is significant. If it's 0.013, are those guys significant? They are not. All that's doing is showing us where. It's a placeholder. I hate that word, but that's what they call it. Yes. Because we don't have a definition for what does it mean by placeholder. That's what it means. Just telling you where the decimal place is. Sir? Right. You could put as many zeros after this as you wanted, and they would all be significant. Because this last one is, so all of these would be between 2, so they are as well. Does that make sense? So that's really all my rules. Those 3, the fourth one that I say is just all other zeros are not significant digits. Does that make sense? If it doesn't meet rules 2 and 3, the 0 is not significant. And I will tell you that it's always very heartening. I get this time of the year when your senior class from last year has gone to college. Very occasionally, I will very nicely receive some emails from them, hey, saying thank you for preparing us and getting us ready for college. And one of the things everybody mentions is they say, man, like the first couple of days, they were hitting on this, and I understood it. And so I'm telling you, this is something you will see again in your college classes. All right, so do be comfortable there. Are you with me? Any questions there? Any questions with those guys? All right. I would love for you to try for me numbers 10 and 11 on page 13. Try numbers 10 and 11.